Let's look at a type of chemistry problem we might call solving equal volume gas problems, where we have two different gases in equal volume containers. So let's start off here. Compare the average kinetic energy and relative mass of two vapors. So we have methanol vapor on the left and ethanol vapor on the right. You see the molecular formulas. You see they have different molecular masses, 32 and 46. The temperatures are at 350 Kelvin. The pressures are higher, 200 versus 400 kPa. Now let's think about average kinetic energy. How is that measured? If you'll reach back into your kinetic molecular theory, you'll recall that the kinetic energy, average kinetic energy, is measured by the Kelvin temperature. The temperatures here are the same. Therefore, you conclude what? You conclude that the average kinetic energies are the same. So the average kinetic energies here in these two containers are equal because the Kelvin temperatures are equal. Now suppose we cut the temperature in each to 325 Kelvin. In which does the pressure reduce more? So on an absolute basis, how many kPa's are lost? Well, if you think about it, if the temperatures are 325 K in both containers, they are the same, so the kinetic energy, average kinetic energy of the molecules is going to be the same. Both of the pressures will go down. However, the pressure on the right, the ethanol, is twice as much as the pressure on the left. Now you can do this with P1V1 over T1 equals P2V2 over T2, and you can then see, since the volume is the same, that the pressure is going to go down proportionately to the reduction in the temperature, absolute temperature. However, on the right, the pressure is higher to begin with. So when you do that calculation, you would expect a greater reduction in pressure on the right than on the left. Even though the relative reduction in pressure is the same, the percent reduction would be the same, there would be a larger absolute reduction in pressure in the ethanol on the right. You can calculate that if you wish. Now compare the densities of the gases in the two cylinders. That will require us to probably do some calculations here. And we can go with with PV equals nRT. The number of moles is the same? No. The number of moles is going to be twice over here because the pressure is twice. And you know from Avogadro's law that the pressure is going to be proportional to the number of molecules. And so we're going to have twice as many molecules here as we are going to have over here. However, we can also realize that the molar mass is 46. So with 46 and a doubled pressure, we're going to first of all see that obviously the density of the ethanol vapor is greater than the density of the methanol vapor. But we can calculate what that difference is going to be by simply, first of all, we double whatever the density is here. We double it to begin with. And then we're going to increase that density by the factor 46 divided by 32, because that's the relative molecular mass ratio. Hopefully these will give you an opportunity to think about how to solve these problems and then do even better on the next test.